So for this section, we are going to talk about this question, which is the 27th problem in Project Euler. So let's see about this question. Okay. Quadratic primes. Euler discovered the remarkable quadratic formula n power of 2 plus n plus 41. For this formula, it will produce 40 primes for the consecutive values from n from 0 to 39. However, when n equals to 40, so the numbers produced by this formula is actually not prime. So he discovered the next formula, which is like this: n squared minus 79n plus 1601 was discovered, which produces 80 primes for the consecutive values n equals to 0 and 79. So the product of the coefficients is negative 79 and 1601, which is this number, the product. So considering the quadratics of this form, n squared plus an plus b, where modulus a less than 1000 and modulus b less than 1000, where n is the modulus of absolute values of n. Let's say modulus of 11 is 11, modulus of negative 4 is 4. Basically, modulus is something that converts your negative number to the positive number, which basically you just remove the sign and that's it. So find the product of the coefficients a and b for the quadratic expression that produces a maximum number of primes for the consecutive values of n, starting with n equals to 0. So you are required to find the product of a and b that produces the maximum number of primes for consecutive term m, which means that you are required to find the combination of a and b such that it produces the maximum consecutive prime, which is from 0 to n. So let's see the code. I'm forcing this question. Okay. Let's see. Maximum a, maximum b. For this maximum a, which means that the term a for the maximum length, the maximum coefficient, is for this case that produces the longest consecutive prime, and this is b. Also, it's for the case that the combination of a and b such that it produces a maximum coefficient. Sorry, the maximum number of consecutive primes. Since a is modulus, which is less than 1000, so a ranges from negative 999 to positive 999. Because negative 999, when you modulus it, it will become 999. So, yeah. And for b, I have optimized a bit. B must be prime, which is common here. B must be prime. Why? When n equals to 0, for this, so b must be prime to create a prime, which means that if this is 0, if n equals to 0, then this part will be 0. So we left b. So b must be prime so that the answer will be prime. So this is a small optimization I did. And L equals to length. This is the function that we use to find the maximum number of consecutive prime numbers. So if L not more than maximum length, which means that if this number, this combination of a and b produces the more consecutive prime numbers, then I will set it, and this is the a and b. So in the end, we will get the product of it, which is required for this answer. So for the length, this is the function that we use to find the number of consecutive prime numbers here. So n equals to 0 first, and then we get the result. This is a formula that is given by here. So I take a and b, then I check. If it is prime, then I add because it's consecutive. Otherwise, I break because the formula produce a non-prime number from given an n, and this the previous number will be the maximum consecutive prime numbers. So I return this n. So let's say for n 30 equals to 39. Because for n equals to n from n equals to 0 to 39, the result produced is consistently prime numbers. So I add n, and when n equals to 40, I get a result. And oh, I found the result is not a prime number, so I just break it and return the maximum length of this combination of a and b in this formula. So this is the prime number checking function. If n and because in this question the number produced by this formula, right, there will be chance to have negative numbers, so I have added a number checking here so that the number that is less than or equals to 0 are not prime number. And yeah, that's it. So it produces the answer as stated here, but I have a small optimization next, which is like this. I use catch. This is some hackish way that I create an array of prime cache. This is to cache the status of the prime number. So the index is the number initially that is 0. So after checking, it should be 1 or 2. If the integer, the value of it is 1, then it is prime number. If it is 2, then it is not a prime number. So this is to be done when I check the prime number and store the result of it, so that I don't have to check it over again if I have checked it previously. And why this? Because for this question, after testing the maximum value that we have achieved is 12,989. So I just take care of the negative part and the positive part, so I times 2. And next I add 1 because 0 is somewhere at the middle, so we need to take care of the 0 slot. Okay, so this is the optimized prime number function for checking whether the number is a prime number or not. So if this is 0, which means that we have yet to check the status of the number, whether is it a prime number or a non-prime number. If we have checked it yet, we have checked it before, so we just ignore the function and get the value from the cache. So if number equals to something, then yes, this is it. So basically this is a prime number checking function. If it is prime, then we set the cache value to 1 and it's not prime, then we set the cache value to 2. So this is the optimize function that should speed up the performance a bit. Okay, so let's check about the performance. The current time milliseconds, and in the end we display the time needed to execute the answer. So for this non-cache function, it is fully. But if we try with the cache version, will it takes faster, shorter time? Yes, it takes a shorter time, much shorter. It reduced by a factor of 2. Previously we have 48 and now we have 21. So 48 divided by 2 is 24, which this cache version is faster than the non-cache version by half, more than half. So this is about this question, and yeah, the answer is as follows: negative 59,231. So you should use dynamic programming when it's possible, when time is not a concern and you want to speed up everything. So this is a nice way to get the answer in a faster way. So that's it about this question. So see you in next section.